Lonely boy. Lonely boy.
Hello, everyone. Oh, let me see. Let me see. Let me see. There you go. Hello, everyone. How you doing? Hello, hello. Can you hear me? The audio is okay. The picture is okay. Everything's okay. Let me see. I have some answers here. How you doing? So, yeah, nearly finishing the week. Well, not finishing the week, but you know, halfway. Hello, I am Sahil. How you doing? Where are you from? Where are you joining from? Hello, hello. Okay, let's give a minute so people can start joining. This is your first Global Hack Week, or I know there's some newcomers, but new new members. But I don't know if you're one of them. Great to see you joining. Okay, both from India. Okay, Prata from India too. That's cool. That's cool. Okay, so everyone's from India, I think. That's great. That's great. What time is it there? It's kind of late, right? It's kind of maybe 2 a.m. or 2 a.m. probably. Oh, okay, 1 a.m. Oh, wow, that's really late. Okay, okay. So thanks for joining, first of all. Okay, let me first of all introduce myself. My name is Nelfo. I've been a coach since a year and a half ago. I'm from Barcelona, and I'm a software engineer. And yeah, that's it. I don't have any rare interest, basic interests. Well, I don't watch movies and stuff like that, but yeah, okay. I was trying to share the screen. So yeah, nothing interesting. We are literally on the grind. Yeah, everyone's from India, I think. Hello, Irwax. How you doing? I'm fine, pretty fine. It's 9 p.m. here in Spain, so it's okay. It's okay. Half half. Can you tell me which languages you have done? Currently, I'm working with Python on a daily basis. Whoops. Let me see what happened with the camera. Okay, I think I got the wrong camera. Sorry for that. I think the other camera just okay. Sorry for that. The other camera just went off. I don't know. Um, so yeah, right now Python. I've done PHP years ago. Golang too. I've done some Kotlin, and yeah, as a backend, that's it. I tried to do a project with Rust. It was a cryptocurrency trading bot. Um, yeah, and it worked, but not great. But yeah, it worked. So yeah, and front end, I've done some JavaScript too. And in the front end, I've done some Tailwind CSS and Angular JS. I don't know if it's full front end Angular, but yeah. Uh, like I have completed C++ and thinking of doing Python with DSA. Is that a nice idea? Yeah, of course it is. Yeah, I think you'll love it. It's much more simpler than C++, but yeah. Nice table and stomach. Yeah. Thank you. Actually, it's yeah. Fun fact. It's kitchen table, like that wood kitchen tables, and I just took one from IKEA and then put four legs, and that's my table. Okay. Just want to ask, is it necessary to do challenges as I'm quite busy with CLH research internship? I'm just attending to learn and can be eligible for MLH fellowship. Yeah, of course. Did you apply to the MLH fellowship? Um, but yeah, probably you can apply with no problem at all. Yeah, but challenges are a plus, of course. Hello, hello, hello. What are your thoughts on Rust and chains using Rust like Solana? Yeah, with Rust, I have like a loving hating relationship. I really like it, but sometimes there's some stuff really a little bit more complex than it could be. But yeah, but it's a cool language. It depends because there's no that much startups using Rust because the learning curve it's a little bit tough, and so if you look probably for jobs in Rust, probably you won't find any much. Obviously, compared to Python, compared to Haskell, probably you'll find a bunch. But yeah. So let's get started. Does anyone know what a privacy coin is, or do you have any idea? Did someone heard about them before, or no? By the way, all these questions you're asking, Patal Dev, I will save them, and at the end of the stream, we can chat and answer them, all of them. If you have any doubts about any college uh, thing or any programming language, anything. So yeah, stay tuned. No privacy, no privacy, no coins, but not privacy coins. Okay, that's cool. Um, okay, no worries. Thank you. Privacy coins are a type of a cryptocurrency. Yeah, actually, they are a cryptocurrency. Mm, first time ever heard of. Okay, okay, that's cool. That's cool. So we have some people that have some ideas. So that's pretty cool. Is Bitcoin a privacy coin? Nope. Uh, not Bitcoin. Monero, for example, it is. We will see some examples and why they called privacy coins and why they exist. What the pros, the cons, the problems they have, the issues they solve, everything. So yeah. Oh, so like Bitcoin, or they are Bitcoin? Obviously, they're not Bitcoin, but they're not like Bitcoin. Okay, so let's get started. This image you can see here, it's kind of probably will be a little bit confusing. No worries, you'll understand this in a moment. So, basically, what are privacy coins? Okay, what is this thing like privacy coins? Some people might think, oh, I thought all cryptocurrencies were private and they were whatever. So, privacy coins basically are cryptocurrencies with, let's call it, privacy enhancing features. So, they're basically designed to be anonymous and reduce, sorry, traceability. Okay, so basically they operate similarly like physical money, cash, sorry, but within a digital ecosystem. Okay, so for example, when you withdraw cash from an ATM or the bank, so the bank maintains a record, okay, but has no way of knowing what you do with that money after this transaction, except if you deposit that money back into an ATM. So basically, the bank knows, okay, this person had I don't know, $1,000 in the account, and they withdrawn maybe 500. So basically, the bank knows that you took out 500, but when you have the cash, they don't know if you gave $5 to your cousin. They don't know if you bought something for $300 because there's no record. They just have like the two transactions: the withdrawal and the when you add money to your bank account. Okay, so most cryptocurrency exchanges that support, let's say, privacy coins, basically require an initial identity verification of users, like the KYC, they call it, know your client or know your customer. Um, However, it's really difficult for these exchanges to track, let's, or more reveal information about subsequent transactions due to privacy coins um, futures. Okay, in this case, so privacy coins are more resistant to tracking than other cryptocurrencies. Nothing is obviously completely anonymous. Those um, well, actually, if you have an investigator with really advanced tracing capabilities, can follow a little bit the movement of the privacy coin, but it's really really tough. Okay, so let's get to the point on how they work. Okay, so basically, privacy coins use different methods to I don't know, conceal identities and transaction histories of their users. Okay, um, these are some strategies. The one you see here on the image, okay, it's called ring signatures. Okay, like this, ring signatures. How do they differ from Bitcoin? You'll see that. You'll see that. I think with this example of the ring signature, you will see the instant difference from Bitcoin. Okay, so let's go. So basically, what they do is they just join together. That's why it's called ring. As you can see, it's like a ring, and it joins together multiple users to hide their individual identities, making it more difficult to determine which user generated a given signature. This is how, for example, Monero, um, obscure the transactions. Let's see this ring signature with an example. Okay, so let's say there was a leak of information at the White House. Okay, and Joe Biden or Donald Trump or whoever calls to the cybersecurity leads and tells them, I know one of you leaked the information, but I can't tell which one. Okay, so how can Joe Biden or Donald Trump, whatever, tell that one of his leads has leaked that information, but not know which one? So this can be basically achieved with the ring signature, and basically it provides an anonymity, and yeah, basically that's it. So basically, you have a bunch of people, you know that someone leaked the information, but you don't know who. So basically, a ring signature is a digital signature that is created by a member of a group, which each have their own keys. So it is not possible to determine the person in the group who has created the signature. Basically, this method was created like 2001, and it was just a proposal. So how you create, first of all, how you create the ring? Okay, who's these people? Why there's these people in this ring? Whatever. So basically, in a ring signature, we define a group of entities, let's call it, who each have their own public private keys. Okay, so everyone has the the private key, the public key, whatever. Okay, so if we want an entity, let's call it I, to sign a message, they use their own secret key. So it's the secret key of I, but the public keys of the others in the group, let's call it S I P 1 to P2, P3, whatever, it should then be possible to check the validity of the group by knowing the public key of this group. Okay, but it's not possible to determine a valid signature in this case if there's no knowledge of the private keys within the group. It's kind of confusing, but it will make sense. So let's see. Let's in this case we have Trent, we have Bob, and we have Alice, and we have Eve in the group. Okay, so let's say that Trent, Bob, Eve, and Alice are in the group. Okay, now we are okay. So these four people in the on the image, um, and they each have their own public and secret key. Okay, now we're good. So Bob now wants to sign a message from the group. Okay, so he initially generates a random value. Let's call it V in this case. Let me see. Yeah, let's call it V. Okay, in this case. Oops, no, not this one. Okay, let me see. Okay, so what I was saying, who was Alice? Oh no, Bob. Okay, so Bob wants to sign a message, so he generates a random value. Let's call it V, as you can see in the image, and then generates a random value. Let's call it X I for each of other participants. Okay, so it will be X 1, X 3, X4, whatever. Okay, X2. So well, actually not X2, but because P is. So for each of other participants, but takes his own secret key. In this case, we call it S1. I think, yeah. Okay. So it's called S. Well, I sorry. S1 or S2 or S3 or S4, whatever. Okay. So in this case, we just have the S1 and the S2. So for each of other participants, they have the random generated value x whatever. So he uses it to determine a different secret key, which is basically the reverse of the encryption function in this case. Okay, so he now takes the message and takes a hash of it, and this creates a key. Okay, the key now we will call it k. Okay, so we have this key will be used basically with symmetric encryption to encrypt each of the elements of the ring. That's in this case it's e key k sorry ek, and then each element of the ring uses an ex or function from the previous element that that we had. So each of the random values for the other participants are then encrypted with the public key of the given participant. So basically, Bob then compute. I think it was Bob. Yeah, Bob. Um, so Bob then computes the value of ys in order to create the ring, and the result of the ring basically must equal to v because it was the initial value. So he will then inverse this value to produce the equivalent private key. So Bob now releases the overall signature and the random X values along with the computer secret key. So to check the signature, the receiver just computes the ring and checks that the result matches the sent signature. So there's some really basic methods here. The generation of the encryption, generation of the random value, the encryption, and yeah, that's it. It sounds kind of confusing, I think, um, but you don't need to know exactly how it works. To be honest, it's like when you use a computer, you don't know how the RAM sends all the messages. So let's see. Let me see if I can. Okay, let me see. Um, if I can find an easy example for you, because I think this example is kind of confusing. Um, mm, I'm looking for a picture. Oh, I can see here a question. Let me first answer the question. Are these co-users randomly selected, or one can choose on their own? And what does it represent? Okay, so um, basically in a signature ring, participants are generally selected by the signer. So this will be like a little bit the process, okay? First of all, you have the signer selection. So the signer um, who wants to create the ring signature selects a set of participants from a group, okay? In this case, so these participants are typically chosen such that their public keys are available. if because some people don't have them. And basically, the signer needs access to a list of public keys. So this could be publicly known keys in a database, a blockchain, or any other repository where the user, well, where users publish their keys. Okay, so the second step, let's call it the inclusion of, the inclusion of participants. So the selected participants, obviously including the signer from the ring. This is just the selection. So the ring can be composed of any arbitrary group of public keys, including the signer's own public key. So the third process is the anonymity. So one of the key features of a ring signature in this case is that it provides anonymity for the signer within the group. So an observer can verify that the message was signed by someone within the ring, but cannot determine exactly who the signer was. Okay, and then the fourth step, we have the signature creation. So basically, the signer creates the ring signature using their own private key and the public keys of all the participants in the ring. Okay, so the process basically ensures that the signature can be verified by anyone. So, but the actual signer remains anonymous among of the group of participants. Okay. Basically, you asked about the selection of participants. This step is crucial. It's a crucial step because it influences the security and anonymity properties of the ring signature. So the signer must carefully choose a set of public keys to form a ring that ensures their anonymity while maintaining the verifiability of, in this case, the signature that we need. I don't know if that answered your question, uh, but yeah. So let me see. See, because okay, let me. Okay, I'll see if I can find a little bit another image. Yeah, the system. I mean, like the algorithm is not something that you really need to deep down and understand every. It's cool to know how it works, but it's not something that you will need in your daily basis. I can see here. Okay, let me see this one. Uh, okay, so never mind. I'll make sure to get them at the end. So, and then we have the second strategy, I would say, in this privacy coins is the stealth addresses. Okay, this is a really important concept. And now I will. So the signature thing was the most the most a little bit complex one because it's a little bit more algorithmic and encryption and whatever. But this will be much easier. So basically, we have the self addresses. So basically, it enables the creation of a new address. Mm, oh, okay, not bad. Because it's really hard with sorry with the light. Um, so we have the self addresses. Basically, it enables the creation of a new address every time a user receives a cryptocurrency. So in this case, Monero uses this method. by generating a public address or a private view key to, to display incoming transactions and a private spend key for sending funds. Okay, in this case, you have like the both parts, like for receiving and sending, and it's quite you know more secure. I think with the lights much better. So, some of you can think, okay, so what's the stealth addresses? How can I benefit from them? How can this stealth address method can help a normal user? So, let's say you're collecting donations. Okay, you have uh, organization, or you're helping an organization, whatever, and you're collecting donations. Um, for a completely transparent standard Ethereum address, a donor might see other transactions received and decide not to contribute. However, with stealth addresses, the recipient financial activity is never visible. Okay, so this could make them more likely to donate because they're unable to determine the amount of donations received already. Okay, so another, I would say, use case or how it can help the normal user, it will be a business could also use self addresses, for example, to pay their contributors or employees in a highly competitive industry. So they may not want their competitors to know how much they're paying to their workforce. So if your competitor don't know how much your employees are being paid, then it's harder to make a better offer and poach them in this case. And the third case, let's say if you have some alpha and don't want to leak it to the world, let's say, self addresses can be used to place trades or make investments privately, putting up an obstacle for on chain analyzers from snooping on your blockchain activity. Um, so yeah, that's, I would say, the main um, use cases I can see there. And then you have obviously some downsides or um, downside. Yeah, downsides. I was looking for another word, but I would say downsides. Okay, let's put um. So there are trade-offs between privacy and social recovery. Okay, where self addresses make it difficult to recover your funds in the event you lose the key or the seed phrase or whatever. However, zero knowledge proofs can solve this in the long term, and for now, it's an acceptable trade-off. If you lose access to your funds held in obviously the self address, so basically you have to give up your privacy to retrieve them, or maybe wait a long time to see that funds. So yeah, and another downside, for example, let's use Ethereum as an example, because everyone probably knows what Ethereum is. So transaction fees for Ethereum must be paid. Okay, so which might reveal the true owner of the self address. For example, if you were to receive an NFT and you cannot send it on to someone else without having some Ethereum in the address to cover the gas fees or whatever, some potential solutions include a way to sponsor some Ethereums when receiving tokens to a stealth address, or by making use of a mixer to fund the address with some Ethereum to cover the gas fees. So there you got some, a couple of downsides. So Also, imagine you hold 0.5 Ethereums in a self address and another 0.5 Ethereums in another address that's known to be yours. If you want to cash out, say 0.75 Ethereum, and you send Ethereum from both of the addresses to an exchange to swap for USDC, then it becomes clear to the exchange and a casual blockchain observer that you are the true owner of the self address. As I mentioned earlier, you need to remain conscious of the limitations. Okay, so if you send money, well, Ethereum, whatever, to your Binance and with another address, obviously, you know, there's a connection there because obviously Binance knows that that address is yours and it's not anonymous as it was supposed to be. Um, it happens with everything. The fight against online surveillance is never over. There are many other aspects of privacy to consider in addition to whatever your Ethereum address is publicly known. So, other than snooping on blockchain data and addresses, there are other weaknesses in the stack, um, such as wallets, browsers, etc. So, even with stealth addresses as the default um, on, let's say, Ethereum, you'd still have to think about metadata leakage, your IP, or whatever. Okay, so take it into consideration. So you can actually use Umbra Cash. Okay, let me share with you Umbra Cash because this one. Let me see. Only the sender and receivers know who received the funds. Send, receive. Okay, here you have a tutorial. Oops, sorry for that. Dark mode, because I know you love dark mode. So we have a batch send or connect wallet. As you can see, you cannot see it, but I have the MetaMask here. Oops. Again. Okay. Let me see if it connects. Okay. So now we have here some now we have our Ethereum wallet connected here. Okay, this is from MetaMask, and basically I can just send here the money, and what it will do, probably I've never used Umbra again, but the intention here. So basically, what it does, okay, it says Umbra is a stealth address protocol. That means it allows a payer to send funds to a fresh address. The address is controlled by the intended receiver, but only the payer and the receiver knows that. Okay, so one way to think of Umbra is this. Imagine if before anyone sent you funds, you send them a brand new, never before used address. Only the sender will know you control that address, which adds a layer of privacy to your payment. So payment via Umbra works similar, but are not interactive. You don't need to give someone a fresh address. They can just generate one they know only will be. Okay, so basically, as this image suggests, Alice sends Ethereum to Bob, and then there's this Umbra, probably smart contract doing something strange here, and well, not strange, but okay, and then sends to the self address, the Bob self address, and then Bob withdraw the money to whatever address to the exchange to probably he can buy something online, whatever. So here you have some other information here. So yeah, there you got. So it's called Umbra. Let me see. Okay, and then we will talk about zero knowledge. Let's call it. It's a strange name. Okay, it's called. It's this. Let me find. I think a picture here. Okay. Okay, probably this one. Let me see. Okay, probably this will be much harder than I think, this image. But let's try. I lost you. Okay, I didn't lost you. There you go. Okay. So let me explain. Let's go. So if you search the name on Google, the ZK Snark S whatever. Let me see how can I explain this. Basically, it involves using cryptography to prove that a transaction is valid without revealing the details of the transaction. Basically, okay. So you don't know the sender, you don't know the receiver, you don't know the amount, you don't know nothing, but you need to prove that the transaction is valid. So for example, Zcash was the first one that used. Let me see here. If we go here, do you know Zcash? Zcash, this one. This one was the first one to use it. It's not going that well. Okay, but it's fine. Okay, pretty cool. Okay, an average cryptocurrency. Okay, so I think it went really. It was sad. 2016, it was 2000. It went down to 40, and then it just went down to 750, and then down to 50, 27. Okay, like an average cryptocurrency um, chart. Okay, so let's go to Monero, for example. Let's see. Okay, yeah, average crypto, average crypto chart. So yeah, Zcash was the first one to implement this system. So now let's talk about the system, okay? Oops, sorry. What is the link to different websites you're using? Um, oh, okay. Let me share it with you. It's this one. Okay, let me share it with you this one. Okay, so are there any risks associated with privacy coins? Mm, yes. Okay. Yes. So let me just finish. Well, it will make something about. It will be more. Your question will be the response will be more like, more the legal part, and the governments, they don't really like these privacy coins, obviously, because they have no control. So there's some legislation stuff there. We will talk about that. But first of all, I want just to close with this third methodology, okay, and just explain a little bit how this. I don't. I just don't want to explain really in detail this thing. Um, let me just see how can I summarize it. Um, okay, so let's talk about basically ZK snarks whatever means zero knowledge, um, succinct, non-interactive argument of knowledge. From argument of knowledge. Okay, so basically, it's, as I said, a cryptographic concept that allows the prover to prove to another party, the verifier in this case, that they know a value of that they know a value X that satisfies some mathematical statement without revealing what X is, and with very little communication between them. Okay, so this is just a simple breakdown. Um, so zero knowledge. Let's just break down the name. The verifier learns nothing about the actual value X, except that the prover knows it and that it satisfies the statement. For example, proving you know the password to a system without revealing the password itself. That's the simple explanation I would say. Okay, so instead of saying your password is clouds, you can say it's something that's in the sky and the prayers, whatever, but without, it's obviously more sophisticated than this, but yeah. So succinct, so basically means that the proof is very short and can be verified quickly, even if the statement itself is complex or involves large computations. The thing non-interactive in the name. So after the initial setup, the prover can generate a proof and send it to the verifier without needing ongoing back and forth communication. So this contrasts with interactive proofs, so which require obviously multiple rounds of communication. And the argument of knowledge, the proof basically convinces the verifier that the prover indeed knows a solution to the statement. Okay, so that's why this name. And now we will see an example. Okay, so are they not legally regulated in countries? They're in the United States, are legal as far as I know, but there's some problems there with other countries. We will talk about that in the next step. So yeah, I just want to wrap up with how the this ZK snarks, because it's a really important point. It's the last one, and it's the one that verifies if the transaction is legit or not. And yeah, I just want to make sure you understand this because it's really important. I have another question here. Are we going to build something using these concepts? Not today, probably in the future, but not today, because this session was meant more for beginners, people that didn't even know about privacy coins, and just so you can know how they work, how the transactions are made, the verifications, everything. So yeah, but we're for this now for this one we're not going to be building like real projects with privacy coins. we will be checking and exploring some of them later on and seeing how many are there and everything. But yeah, sorry for that. Okay, so how it works. Okay, so you might think, okay, Nofal, you tell me a lot of information, but I just want to know how it works and how to verify. Just simply just explain it simple. I don't want to know any cryptography, algorithmic transaction thing or whatever. So basically, first of all, you have the setup. Okay, so a trusted setup phase generates some common reference parameters that both the prover and the verifier will use. Okay, basically, this phase involves creating some cryptographic keys. The second part will be the proving. So the prover uses the secret value parameters to create a proof. So this proof shows that X satisfies the statement without revealing X itself. Okay, so and then we have the third part is the verifying. So the verifier uses the proof and the common parameters to check the validity of the proof. So if the proof checks out, the verifier is convinced that the prover knows X and that X satisfies the statement. Basic. So let's put an example because probably it will be easier. So imagine you want to prove to someone that you know the solution to a complex Sudoku puzzle without showing them the solution. Okay, so you know Sudoku. Um, Sudoku, just in case. Okay, this game, probably you've heard about it, that you have to arrange numbers to. Okay, so okay, so first of all, the setup will be both you and the verifier agree on the rules of Sudoku and the initial setup of the puzzle, okay, with the common reference parameters. And then in the proving phase, you use your knowledge of the solution to create the proof that you can solve the puzzle, okay? The proof doesn't reveal the solution, but shows you followed Sudoku's um, basically the doesn't reveal the solution but shows you followed the Sudoku rules correctly. And then in the verifying part, the verifier checks the proof against the rules and the initial setup. If the proof is valid, the verifier is convinced you know the solution, even though they don't see it. Okay, so it's a really small example, but yeah, I think you probably have an idea. Um, okay, so privacy coin bans. Okay, so let's go with the question we had before that if uh, I don't remember. Okay, are there any risks associated with privacy coins? Okay, here we will talk about some privacy coin bans. Basically, privacy coins are legal in the United States, but all other major world economies have imposed restrictions in an effort to curb money laundering and reduce organized crime. Okay, basically, Japan banned privacy coins in 2018. South Korea and Australia followed suit. The listed Monero, Dash, Zcash, and other coins from exchanges. And then we have Dubai. Dubai is the latest country to join this list, and it was 2023, as far as I remember, with other jurisdictions such as the European Union considering bans. Okay, so in Europe it's not banned, but they were considering to ban it. So yeah, and basically the considerations was because a leaked draft of a proposed money laundering bill written by the European Union uh, stated that credit institutions, financial institutions, and crypto asset service providers shall be uh, prohibited from keeping anonymity enhancing coins. Okay, so basically privacy coins. So, and several mainstream exchanges have also stopped offering privacy coins. I don't know if you know Bittrex. So if you, this one is Bittrex. Let me show you. So this is an exchange. Oops, no, I think it's not this one. Not this one for sure. Oh, okay. I think Bittrex went to die, so it's not longer active. But yeah, I think Bittrex, because I remember it was 2 years ago or so. Um, Basically, they removed some privacy coins, and yeah. So I think Kraken is still active. Kraken, this cryptocurrency. Um, let's go to see prices here. Sorry for that. I think they have Monero, but they have some restrictions because what they do is they don't have like Monero. They have like something. I don't know if it's like you're not buying the cryptocurrency itself. It's like a derivative or something like that. I don't know exactly. So yeah, basically, Kraken. I think Kraken Monero UK. I think it was just in UK. Okay, so here you can see UK hates Monero. Kraken does not support Monero anymore. Okay, I think it was just in UK and Australia. So, okay, here we have another new from April. Kraken set to the list Monero in Ireland, Belgium. Kraken is the listing top privacy coins, Monero, for the same reason I told you before. It's because they don't like them. By the way, just they because there's some laws anti money laundering whatever thing. So yeah. So now you might think, okay, so the countries don't like that. Every you know cryptocurrency exchanging platform delisted. So what's the future? The future of the privacy coins? Why am I even learning about them? Okay, so let's see. So the future, basically, as a cryptocurrency ecosystem advances, we will continue to see tokens with diverse use cases and characteristics. Okay, that's 100%. So privacy coins have challenged traditional blockchains by providing means of transacting with greater anonymity and flexibility. Okay, but have also raised questions about transparency and trust. So to maintain a safe cryptocurrency ecosystem, neither full transparency nor total anonymity is ideal. So regulators require appropriate levels of legal authority and oversight to reduce malicious activities and protect participants. So whether with privacy coins or other cryptocurrencies. But at the same time, businesses require tools to track illicit activities and preserve, sensitive information. And Bitcoin represents a balance between the two, promoting privacy and financial freedom while offering enough transparency to prevent abuse by bad actors. Okay, so there you go. you have this good news, this bad news, kind of confusing. And now we'll go to see some privacy. Let me see. You have a question here. Are they not legally regulated in countries? They are, but there's some countries that they don't like it for that reasons. For the transparency, because it's really hard to track some transaction from private coin, with all this shuffled, with all these transactions, because like, you don't know anything, you just know that something was sent some date somewhere, and that's it. So yeah, probably. Well, so the reason they say is not the reason, probably it is, but I don't know if they say that it's for privacy, for for preventing money laundering, organized crime, and all that stuff. So it's okay. But maybe there's some other part of the population that think, okay, they want to control us, whatever, blah blah blah. Maybe it's a reason. Maybe it's really they care about the organized crime and everything. So I don't know. It depends on when you want to put the weight on the balance. So yeah. Uh, 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 Let me see. Okay, let me. Okay, I was looking for Queen algorithm. Oh, okay. I have a question here. Do privacy coins have any disadvantage over other coins? Okay. Uh, yeah. I think do they have some disadvantages compared to other cryptocurrencies? Um, I would say first of all, and the last one we talked about is the regulatory scrutiny. So the compliance issues. Privacy coins can be challenging to regulate. Okay, leading to stricter scrutiny by governments and financial institutions. So some countries have banned or heavily regulated the use of privacy coins due to concerns over their potential use in illegal activities such as money laundering, tax evasion, crime, everything we've talked about before. And then, besides the regulatory, we have the exchange the listing. So, okay, so that comes in hand with the last point to compliance issues and regulatory concerns. So, due to regulatory concerns, some exchanges might be, you know, reluctant, let's say, to list privacy coins, reducing their liquidity and accessibility. And, and the other point, disadvantage, I would say, is the complexity and the performance. Okay, so the complex implementation technologies like ZKSR and ARKS, like the picture you're looking right now in the screen, are complex and can be really difficult to implement correctly. Okay, and this complexity can lead to potential security vulnerabilities if not handled properly. And then besides that, we have sorry for that. Sorry for that. And besides that, we have transaction speed and costs. Um, Yeah, transaction speed and costs. Basically, privacy coins, private coins, technologies can increase the computational overhead, potentially resulting in slower transaction times and higher fees compared to other cryptocurrencies. And then we have the network effects and adoption. Basically, it's there's a limited acceptance. So due to regulatory issues and lower visibility, privacy coins might have less adoption and acceptance among merchants, sorry, businesses and users compared to more well-known cryptocurrencies like Bitcoin or Ethereum. And there's um, I would say smaller communities and ecosystems. Privacy coins often have smaller communities and fewer developers working on the ecosystem, which can slow down innovation and the development of new features. And then you have the transparency, the auditing, and is the lack of transparency. It's one of the pros and the cons at the same time, in my opinion. While the lack of transparency is a future in this case for privacy, it can also be a drawback. Okay, it can be harder to audit and verify the integrity of transactions and the overall network, which could potentially hide fraudulent activities or even errors. Okay, um, mm, I would say user accountability. With high level of privacy, it becomes challenging to trace and recover stolen funds in case of theft or fraud, whatever, making users more vulnerable if they lose access to their wallets or are targeted by malicious actors. And then the final point I would say, because I don't have more ideas, it will be the user experience, the adoption barriers. One of them, the user experience. Uh, the additional steps required to maintain privacy, such as using specific wallets or following certain protocols, can make the user experience less straightforward compared to more mainstream cryptocurrencies. And I would say the educational gap. Okay, users need to be educated about the importance and use of privacy features, which can be a barrier for widespread adoption. I don't know if uh, that responds your question. Sorry, let me see. Okay, okay. I don't know why I just getting the question. I don't know if you send in the question, but sometimes it's a little bit laggy. Let me see. Queen algorithm. Okay, this is okay. I think this one we already responded. This one. So is ZKSN arc somehow related to ZK Starks? Okay, yes. So basically, ZK Snarks and ZK Starks are both crypto. Oops, are both cryptographic protocols used to create zero knowledge proofs, but they have some differences. And let's see some, if you want, some similarities and some differences. So similarities, I would say that zero knowledge proofs. Okay, that's the first of all. So both um, are designed to allow prover to convince a verifier that they know a solution to a problem without revealing the solution itself. So that's the same. And then the non-interactive part. So both are non-interactive, meaning that after an initial setup, the prover can generate a proof and send it to the verifier without needing ongoing back and forth communication. So the third point, I would say succeedness. So both aim to create proofs that are short and can be verified quickly. So even if the underlying computational is complex, okay. But differences, I would say um, the setup, okay. So ZK Snarks requires a trusted setup phase to generate cryptographic keys. So this setup must be done securely because if the keys are compromised, the security of the entire system can be undermined. Okay, and the ZK Starks with K do not require a trusted setup. They use publicly verifiable randomness to generate the necessary parameters, which enhances their security and transparency, obviously. And then we have the scalability, if you want to see it that way. ZK Snarks with N. Um, it's really efficient. They can be less scalable to the trusted setup and the complexity of the underlying mathematics. Um, they have a bunch of elliptic curve pairings and a bunch of stuff, so it's a little bit complex. And the ZK Starks with T, basically, they are designed to be more scalable. They support large computational, and it's more efficient for verifying large amounts of data. So yeah, basically, those protocols are considered to be more suitable for applications that require high scalability. So yeah, and in terms of performance, cryptographic assumptions, and that stuff, they have some key. Okay, governments might bind privacy. Oops, let me see. Just close this. I don't know why. Oops. Okay, sorry. So governments might ban privacy coins, but why would decentralized exchanges allow them? A DEX might not be directly affected by usage of a privacy coin. Can governments exert influence over decentralized exchanges? Okay, let's say decentralized exchanges, okay, DEX operate in different manner compared to centralized exchanges, and they're typically designed to be resistant to control by any entity, whatever, including even governments. However, there will still several reasons why decentralized exchanges might choose to list privacy coins, or why they might be pressured into doing so. um, First of all, the legal compliance and liability they have. So developers and operators, in this case, while decentralized exchanges are decentralized, they're often created and maintained by identifiable teams and organizations. So these developers and operators can still be subject to legal actions or pressure from governments. Okay, so the second point will be avoiding to avoid legal risks. So to avoid potential legal risks in liabilities, developers of decentralized exchanges might choose to delist privacy coins, uh, just to prevent any legal risk, legal actions against them or whatever. And then the regulatory pressure, uh, and it's a indirect influence. So governments might exert indirect influence over decentralized exchanges by targeting associated services such as domain registers, web hosting providers, other infrastructures that support the DX, X or whatever. And and there's some compliance threats because by making an example of high profile cases, governments can create a chilling effect, discouraging decentralized exchanges from listing privacy coins to avoid becoming targets themselves. So, yeah. And then there's a bunch of reasons we could talk about: users and community considerations, reputation and trust, user base, resource allocations, technical challenges, fiat on ramps and off ramps, cross-platform compliances, a bunch. So even if they're decentralized, sometimes there's a lot of you know things that might make them choose not to list them. Okay, so we will take a quick stop, just to grab some food and some snacks. Just 5 minutes. Just let me grab a timer. Okay. Okay, I have the timer. So see you in 5 minutes, and we will see the other part. If you have any question, just put it on the comments. Uh, during this time, and I will make sure to respond them ASAP. Well, once we are back. Okay. So yeah, that's it. So thank you so much, and see you in 5 minutes. Okay. If you have any question, just put it on the comments, and I will be back. We will be back in 5 minutes. Okay. I will just put here the banner. So yeah, see you in 5 minutes, folks. Have a good one. Let me put you some chilling music. Let me search song. Okay, this one. You like this one? Okay, there you go. So 5 minutes. Okay, thank you. See you right now. Hello. Hello, folks. How you doing? Everyone's okay? Okay, let me see. Let me see. Um. Okay. So, in this pause, I realized that we missed some use cases. Let me see. Sorry. Hemlo, Hemlo. How you doing? Yesterday I learned what it was Hemlo, Hemlo. Because I had never heard of that before. But yeah, now I'm a pro. Okay, so take care. Okay, so let's talk about um use cases. Okay. Um. Okay, this point will be a little bit. It will be just quick. Just want to make sure. Noise. What are you doing? Okay, I see. Oh, noisy means nice. Oh, okay. I thought that maybe the noise was there was no noise or I was muted or something. Okay. Thanks. I feel like really old. Uh, yeah, always learning something with you. So, let's talk about some use cases, okay, of privacy coins. Um, so the anonymity of the privacy coins has led many to believe that they're primarily used for money laundering, hacking, terrorist financing, whatever. So, although malicious activities certainly occur on the blockchain, we have observed that most criminals still use Bitcoin because it's cross-border, instantaneous, and liquid. Privacy coins are typically not as liquid as Bitcoin, making it more difficult for criminals to acquire them and cash out into fiat currencies. So many argue that privacy coins serve important purposes. For example, 2022, sorry, it was 2020 report by U.S. Law firm called Perkins something found that privacy coins do not pose more often inherent risk to anti-money laundering obligations than other cryptocurrencies. Okay, like the same or even less. So the paper further detailed that um, benefits of privacy coins are much greater than their financial risks. Okay, so the balance probably is more positive than negative. Um, yeah. So let's see a couple of let's call it legitimate use cases for privacy coins. The first one will be reducing authoritarian financial control. Okay, this will be especially beneficial in countries such as China, Russia, North Korea, where government may use CBDCs and other blockchain-based applications to monitor financial activity and exclude individuals or businesses from the economy. Okay, so here the private coins will be huge. Probably not in North Korea because it will be kind of difficult to you know to, to teach people about cryptocurrencies or have an exchange there. uh that would be a challenge for sure. But yeah. And then we have the second point, and it will be protecting sensitive information, because individuals might want to obscure their wallet wealth and purchases to avoid scrutiny. For example, wealthy cryptocurrency holders have additional incentives, such as making donations off the grid and reducing exposure to hackers seeking, large exploits. So yeah, we've talked about the future and everything. So kind of interesting, kind of interesting. Obviously, there's more use cases. It's far more than that one. You know, with uh, I don't know, it's censorship resistant, uh, anonymous donations and fundraising, private investments, and wealth management. There's a bunch of industries. So yeah, some examples. Let's see some private coins. Mm, okay, let's see here. These are some private coins. Okay, they're listed from the bigger one. As you can see here, um, the you know the market cap is small. Uh, it's like 12 billion. Yeah, 12 billion. You might think it's a lot, but as you can see here, the total cryptocurrency market cap is like 2 point. What is it? I think it's more like you know 2 2.5 trillion. Okay, so 2.5 trillion uh, compared to 12 billion, it's nothing. So the the market cap is really, even if even the biggest one is Internet Computer ICP. The market cap is 4.7 billion. Monero is 3.1 billion dollars. The volume is the last 24 hours 109 million. If we compare that to let's go to Bitcoin, for example. This is okay. So it doesn't even make sense. We have 36, nearly 37 billion dollars the last 24 hours on volume, and here we have 100 million. Okay, okay. So even if we go to uh, Gala, okay, Uh, Gala is like, I don't know, the number 71 of cryptocurrencies. You've never heard about it before, probably. And the volume, the last 24 hours, is more than the second biggest, um, privacy coin on that is Monero. So imagine the volume. Obviously, the volume is not that big because we've talked about all the reasons, all the pros, all the cons. Here we have another great cryptocurrency called Sad Hamster. It's this one. Man, uh, they just they just create random cryptocurrencies all day long. Maybe there's okay. This one is relatively new. It was released on mid May. Okay, it was like 3 cents. It went up to nearly 7 cents, and then it went back to 1.8 cents, and then again. So this is just sometimes it's just a joke. Obviously, there are meme coins, like this one called Hank. You know, you cannot take this seriously because you see like the graph. Well, this is a little bit stable, but okay. So this is 7th of May. Well, it's at least it's a little bit stable. There's one here in Spain that was called Pambi coin. Obviously, it was a scam because, as you can see here, I think it was a YouTuber here in Spain that created this cryptocurrency, pumped it up around here, and then he sold everything and just run out with the money. So, as you can see here, well, kind of sad, but yeah. So. Let me see if there's any question. Uh, Sad hamsters will go to nonsense. Actually, I really, I don't know if it's the meme thing, like the hamster with the violin, like I really like that memes. I love them. Really funny. But what it's not funny is the chart. Okay, so we should invest into sad hamster. Probably someday will be happy hamster something. So yeah, can we create our own crypto? Is there any requirements? Yeah, you can fork Bitcoin, make fork changes, and just deploy your cryptocurrency. No, it's not that hard. I cannot give you like the instructions right now, but it's not that hard. Okay, a YouTuber did it, so probably won't be that hard because there's like 20,000 cryptocurrencies out there, and probably the hardest part will be, to get your crypto into an exchange, for example, Binance or something. Probably they will require you some, you know, some, I don't know, something, but I have no idea, to be honest. But yeah, for sure you can create it. Yeah, meme coins are pretty silly. Yeah, they're pretty silly. I mean, like, I don't know, if uh, if you get a bunch of them at 0.02 cents and sell them at 0.04 cents, probably you'll make 100% of your money. So it's not that silly. But if you buy at 7 cents and you just go down to 1 cent, so probably it's like the worst investment you could ever make. So yeah, these are the privacy coins. There are a bunch. So we've talked about the advantages, what you can expect from them, everything. So your decision. This was obviously just an introduction to show you how they work, what's the differences, everything. Okay. Let me see. Okay, can you hear me? Any docs or materials for making a crypto? Just let me search that for you. How to make a cryptocurrency. Okay, let me see. How to create a cryptocurrency. Not this one. I don't like it. How to create a cryptocurrency. Nope, I don't like this one. 3 easy steps. Blah blah blah. By blockchain, how to make. Okay, so there you go. You have 7 steps. Okay, you have define your objective, choose a consensus algorithm. Okay, so probably you have to build it over uh, an existing blockchain, like Ethereum blockchain or Solana blockchain, are I think the most common ones. Um, so choose a blockchain platform, then create the nodes, design the internal architecture, generate wallet address, integrate the API. So these are the steps. There you go. Probably you can, let me share with you this link. It's really risky though, similar to penny stocks. Yeah, yeah. More risk, more return, but obviously you could lose it all. You can, just use buy some some warrants from like crude oil. Let's see. Let's go here. Products. This is a bank. You can just go here. 101. You can go here, and you can risk all your money into this multi-warrant limited of 10 years US Treasury note futures, um, expired on 24th of September. Probably you can do that if you want, but yeah, let me see. Oops. Okay, there you go. You have a bunch of risky um, derivatives if you want. Besides, or you always have PAM Bitcoin. Okay, you can just wait for the next one and boom, buy here, and then wait, and then sell here. Okay, this is, I think, the best strategy you can ever ever make. Um, so yeah, I think that's it. Um, thank you so much for being here. Thank you so much for being here for the last 2 hours. I really appreciate your time. I'll just go to sleep. Tired. Um, hope you had fun. Hope you learned something. Hope you um, just fold your curiosity with some data, some information, some random facts, and everything. So thank you so much for being here, and yeah, thank you to Samia Kaditya and Pratam Vis. Okay, Pratam Vis. Thank you so much for being here, and see you on the next one. That will be tomorrow. Tomorrow at I think it's tomorrow at 4 p.m. Eastern time, and it will be more about. You will see that. Yeah, you'll see that. It will be about DAOs. So yeah, thank you so much. Hope you have a great day. Hope you have a great night, great dinner. Uh, Pratambis. Yeah, sorry for that. Sometimes it's kind of difficult. And it's Pratam. Oh, okay, okay. Sorry for that. Okay, that's cool. That's cool. Uh, good night. I will also go to sleep now. Yeah, good point there. Okay, so thank you so much. Have a great one. If you have any question, don't hesitate to ask me on Discord. I'll try to help as much as I can. And yeah, see you on the next one, folks. Have a good one. Good night.